Ancient Indian science that shocked the world. A detailed chapter-wise exploration. Chapter 1. The birth of zero. India's greatest gift to mathematics. 1.1 The origins of zero. The concept of shunya, void or nothingness, is mentioned in Vedic texts 2000-1500 BC, highlighting early Indian philosophical thought on emptiness and abstraction. The Bakshali manuscript 3rd 4th century CE, discovered in 1881 in present-day Pakistan, contains the earliest recorded zero symbol used in calculations. Brahmagupta 6-8 CE formalized the mathematical rules for zero in his seminal work, Brahmasphytasiddhant, which defined zero as a number and laid the foundation for modern arithmetic. 1.2 How zero changed the world. Zero enabled the place value system, making advanced calculations possible. This innovation was vital for algebra, calculus, and computer science. Indian numerals and the concept of zero were transmitted to Arab scholars al-Khwarizmi, 9th century CE, influencing European mathematicians like Fibonacci 1-0 CE and paving the way for modern mathematics. Without zero, complex computing, financial transactions, and modern scientific advancements would be impossible. Chapter 2. The decimal system foundation of modern mathematics. 2.1 India's numerical revolution. The Lakavibhaga 5th century CE Jain text records the use of decimal numbers and demonstrates the advanced numerical understanding of ancient India. Aryabhata's Aryabhata for 99 CE employs a place value system, using Sanskrit syllables for digits, eliminating ambiguity in calculations. 2.2 Global adoption. Arab traders named these numerals Hinsa from India, and they later became known as Arabic numerals in Europe. Fibonacci's Liber Abaci 1-02 CE introduced Indian numerals to Europe, replacing cumbersome Roman numerals and revolutionizing calculations. Chapter 3. The Pythagorean theorem found in India 300 years before Pythagoras. 3.1 Bodhaina's Sulba Sutras 800 BC. The Sulba Sutras provide rules for altar construction, stating, the diagonal of a rectangle produces both areas which its length and breadth produce separately. This statement is an early form of Pythagoras' theorem, predating Greek and Babylonian versions. 3.2 Later developments. Epistamba and Katyayana expanded on these geometric principles, applying them to architecture and astronomy. Ancient Indian mathematicians proved the theorem through geometric constructions, influencing later studies. Chapter 4. Calculus and Infinite Series. Kerala School's hidden genius for. 1 Madhava of Sangamagrama 134014-5 CE discovered. Infinite series for pi, known today as the Madhava-Leibniz series. Taylor series expansions for sine and cosine functions. Centuries before Newton, Nilakantha Somayaji refined planetary models using calculus-like concepts. 4.2 Why wasn't India credited? Kerala's work was unknown in the West due to geographical isolation. European scholars Newton and Leibniz independently developed calculus. But centuries later. Chapter 5. Astronomy, Heliocentrism and Earth's rotation. 5.1 Aryabhata's revolutionary ideas for 99 CE proposed. Earth rotates on its axis, explaining the phenomenon of day and night. A heliocentric model where planets orbit the Sun, centuries before Copernicus, calculated Earth's circumference with remarkable accuracy. 5.2 Later astronomers. Bhaskara 211141185 CE described an early form of gravitational attraction. Objects fall due to Earth's attraction. Varahami Hira 6th century CE predicted eclipses and studied comets. Chapter 6. Ancient Indian medicine. Sushruta, the father of surgery. 6.1 Sushruta Samhita 600 BC described 120 plus surgical instruments, scalpels, forceps, needles, rhinoplasty, nose reconstruction techniques. Cataract surgery using the couching method, introduced anesthesia with herbal extracts and wine. 6.2 Ayurveda and pharmacology. Charaka Samhita 300 BC details 700 plus medicinal plants and therapeutic treatments. ancient plastic surgery influenced modern surgical procedures. Chapter 7. Atomic Theory. Kanada's Vaisheshika Philosophy. 600 BC. 7.1 Anu atoms, the building blocks of matter. Kanada theorized, matter consists of indivisible particles, Anu. Different combinations form elements: earth, water, fire, air, ether. Predates Greek atomic theory. Democritus, 5th century BC. Chapter 8. Metallurgy. The mystery of rust-free iron. 8.1 The iron pillar of Delhi, 4th century CE, 1600 plus years without rusting due to high phosphorus content in the iron, demonstrates India's advanced metallurgical knowledge. 8.2 Wootz steel. The legendary Damascus sword, high carbon steel produced in South India, 500 BC. Exported to the Middle East and used in Damascus swords. Chapter 9. Fibonacci sequence hidden in Sanskrit poetry. 9.1 Pingala's Chandas Shastra, 3rd century BC. Described binary sequences and Fibonacci numbers in Sanskrit poetic meters. Predates Leonardo Fibonacci 1202 CE by 1,500 years. Chapter 10. Why were these discoveries forgotten? 10.1 Transmission and lost credit. Many works reached Europe via Arab scholars without Indian attribution. Colonial-era biases suppressed recognition of Indian contributions. 10.2 Rediscovery and modern recognition. Scholars like C.K. Raju and George Gevorgis Joseph highlight India's role in shaping global science. UNESCO now acknowledges the Bakhshali manuscript 0 as a World Heritage Discovery. Conclusion. India's scientific legacy. Ancient India was a powerhouse of innovation, with discoveries that shaped modern science. From zero to surgery, calculus to astronomy, these contributions remain foundational.